Hi. In this video of import, we are going to be discussing the concept of rank criterion of consistency. The first thing to recall is that, yes. So the first thing to recall is that, we have so far dealt with systems of linear equations where number of equations were equal to number of unknowns. Then we dealt with equation systems where number of equations were less than the number of unknowns. And here you were introduced to a concept called consistency, which had to do with, as I mentioned there, the existence of a solution. Okay. Now we are going to formalize this notion of consistency, and we are going to put conditions on the ranks of the augmented and the coefficient matrix to understand in which cases would you have a consistent solution vis-a-vis not. Um, uh, and this criteria is going to be based on the ranks of these matrices. So if rank is something that you're still not familiar with, I would suggest stopping this video right here and going back to the concept of rank and understanding that impeccably well, because without it you wouldn't be able to follow this video. Okay. So for the rank criterion of consistency, the first thing that you start with is the coefficient matrix and the augmented matrix, which is just the coefficient matrix and the column of vectors attached to it. For consistency, the primary condition that you have is that the rank of the coefficient matrix should be equal to the rank of the augmented matrix. In this case, you would say that the system of equations is consistent. With a consistent system, you can have two types of solution. One is a unique solution, the other is an infinite solution. Unique solution would imply that the rank of A is equal to the rank of A star, which is equal to the number of unknowns. Whereas in an infinite solution, the ranks would be equal but would be lesser than the number of unknowns. Okay. Um, so the first question, type of question that you have here is, are the following systems of equations consistent? Okay. And you start with the following steps. You calculate the rank of A, you calculate the rank of A star, you see what the relationship between the two of them is, and you conclude based on these conditions. These conditions are things that you must remember at all times. This is something that you must memorize, although even though it's very intuitive, but it's still something that you should memorize, so that you can always identify, not identify, but verify your answer at the end of the day. Okay. So here you can see that A is clearly an upper triangular matrix. Determinant of A is equal to 1 into 1 into minus 1, which is equal to minus 1, which is not equal to 0, which implies rank of A is equal to 3. Okay. Now, here's the thing. Okay. This is very important. Consider A star. Okay. The maximum rank that A star has is M cross, so the A star matrix is actually M cross n plus 1, right? Which means that the maximum rank that A has is actually M, right? The minimum rank that A star has, on the other hand, is equal to the rank of A itself. Why? Because A is fully contained within A star. Therefore, the minimum rank of A star is actually equal to the rank of A, which is, in this case it's 3, which is equal to n, but it could be anything else. But the point is that the minimum rank of A star is always the rank of A. So the minimum rank here is 3, the maximum rank here is 3, which means that the rank is 3, right? And this is also obvious because, like I said, the A is fully contained here. So if rank of A is 3, then rank of A star is also equal to 3. So this is just what I said in a slightly cleaner manner. Now that you've established that rank of A is equal to rank of A star is equal to 3, this is the first step of your answer. The second step involves making a conclusion on the type of system, which is in this case a consistent system because both the ranks are equal. And the third involves making a comment on this type of solution, which in this case is a unique solution because the rank is equal to n, right? So you have a unique solution. Always give your answer in these three parts, because if you don't, then it's going to be very difficult for you to score full marks. Okay. Now you come to this particular question. Here, you can clearly see that there is a row of zeros in A, which implies the determinant of A is equal to 0, which implies rank of A is less than 3. Now consider M33, okay, which is equal to 7 into 1 minus 0, which is equal to 7 minus 0, which is equal to 7, which is not equal to 0, which implies that rank of A is equal to 2. Okay. Now, the maximum rank that A star can have is 3, right? Because it's a 3 cross 4 matrix. So the maximum is a 3. Okay. And the minimum is a 2, which means that now you just need to check if it can have rank 3. Otherwise, it has rank 2. Okay. So if you look at it, this here, the rank of A star, because of this row of zeros right here, okay, first of all, ignore this statement. This is an incorrect statement. Okay. So this is just ignore this statement. Yeah. But because you see a rank, row of zeros here, what this tells you is that there is no 3 cross 3 determinant which does not contain a row of zeros. What does this imply? This implies that there is no non-zero 3 cross 3 determinant, which implies that rank of A star has to be less than 3. So out of the two options that you had, if it's not 3, it has to be 2, which implies rank of A star is equal to 2. Okay. Let me just erase the ink on slide. And yeah. So you can see that, again, ignore this statement. But yeah, you can see that this is the statement that you have here. And again, so you have rank of A equals rank of A star equals 3, which is less than, equals 2, which is less than 3, which is basically n, right? So you have a consistent system and you have infinite solutions because it is less than n. Okay. Okay. Now we come to the last example. Again, you have a matrix A. Here you can see that determinant of A is equal to 0 because row of zeros, right? Which implies rank of A is less than 3. Again, if you consider M33, it's 20 minus 0, which is equal to, M33 is equal to 20 minus 0, which is equal to 20, which is not equal to 0, which implies rank of A is equals 2. Now you have A star here. Again, the maximum rank that A star can have is a 3. The minimum it can have is a 2. So you need to check for 3. Okay. So consider the determinant which, so you start from the determinants which are upper triangular so that you can, sort of minimize the work that you have. So if I were to write this out, it would be something like 100 minus 4, 20, 0, and 8 minus 18, 7. I have just picked this column, and this column to make a determinant. Yeah. Now, because it's upper triangular, the determinant value is equal to 20 into 7 into 1, which is equal to 140, which is not equal to 0, which implies that rank of A star is actually equal to 3. What this implies is that rank of A is no longer equal to rank of A star. Therefore, it's an inconsistent system with no solution. Okay. All right. This is exactly. I've considered a different determinant here, but you can always consider the upper triangular one. That's easier to calculate. Here are the key takeaways from this exercise. The first thing is that the rank of A star can never be less than the rank of A. This is because A is fully contained within A star. This is a fairly intuitive result. The second is that the rank of A, when the rank of A is equal to the maximum rank, which is in this case equal to n, then you do not need to calculate the rank of A star at all. Why is this? Because the maximum rank of A is equal to n. Why is that? Because you've discussed cases when m equals n and you've discussed cases when m is less than n, which means that in both of these cases, the maximum rank that A can have is n, right? Because it's always the lesser of the two numbers. Does that make sense? The maximum rank of A can be equal to n, because in the case when m equals n, the rank of A would can at max be equal to n. When m is less than n, then the maximum rank that A can have is actually equal to m, which means that if you consider both of these cases, together, the maximum rank that A can ever have is equal to n. Yes. Similarly, A star is actually given by m cross n plus 1, right? Again, so the maximum rank that A star can have is equal to m, right? Because it can never have a rank n plus 1. When is it that rank of A would be equal to rank of A star? Okay. When rank of A is equal to rank of A star, you know that the system is consistent, right? So essentially what you're saying is the following. When the rank of A is equal to the maximum rank, which in this case is equal to n, then it automatically implies that rank of A equals rank of A star. Okay. Because the maximum rank um, that A star can have is equal to m, and the minimum rank that A star has is equal to the rank of A. If the rank of A is equal to n, okay, then it automatically implies that A star also has rank n, right? Because it cannot have a rank greater than n anyway. Yes, which implies that rank of A is automatically equal to rank of A star when rank of A is equal to the maximum rank. If this is still not clear to you, rewind the video and you will be able to make sense of it. All I'm saying is that when, so I have some space here. All I'm saying is the following. When rank of A is equal to the maximum rank, this automatically implies that rank of A equals rank of A star, which is equal to n, because the maximum rank that A can have is anyway equal to n, right? Which implies that this is a unique solution. Automatically, it's the first case, right? So you don't need to calculate the rank of A star at all. You automatically know that it's a unique solution. Okay. The last thing is that if rank of A is not equal to the maximum rank, then you go forward as the following method that we have discussed. You calculate rank of A, calculate rank of A star, see the relationship between the two to decide upon the type of solution. This concludes our second last topic of the system of linear equations unit. The next thing that we're going to do is one of these same questions with an additional unknown in terms of the constant vector, and that is going to be a part of the assignment video next. And the last thing that we'll then do is the homogeneous system of equations, which is the last topic for this unit. Thank you.